Hello students, in this video I'm going to be showing you how to solve linear systems, systems of linear equations using three methods. One method that I'm going to be using is the substitution method, where we substitute the value of one variable into another equation. The second method is the graphing method, where we graph two lines and find their point of intersection. And the third method is the elimination method, where we find two opposites or inverse terms and eliminate them in order to make the equation easier to solve. Or the equations easier to solve, I should say. Here we have three different systems of linear equations. What I'm going to do first is walk you through how to select one of these methods to solve linear equations, because sometimes it's not always obvious which one I should use. Should I use substitution? Should I use elimination? Should I use graphing? Which one should I use? So I'm going to give you a compelling reason why to use the different types of solutions, either by using graphing, by using substitution, or by using elimination. So pause the video for a moment to try to figure out which of these methods should go with which of these systems of linear equations, and then come back to see if you are right. All right, for this first system of equations, we said that elimination was a method that we were going to use. This method works well in the linear system because there are two inverse terms, the 2x and the negative 2x, those are inverses of each other, that will eliminate or cancel out when we add the two equations together. So these two terms, I'll highlight them here in green. This term, the 2x, and this term, the negative 2x, when I add these two equations together, 2x plus negative 2x is equal to 0, then I'll just have to do 5y plus negative 7y, and then negative 2 plus 6. So it'll make the equation, the system of equations, rather easier to solve. Let's take a look at the second one. For this next system of equations, we're going to be using the graphing method. Reason being, the equations are both in slope-intercept form, y equals mx plus b, right? Y equals mx plus b, y equals mx plus b. Since that is the case, we can easily identify the slope and the y-intercept, right? If they both say y equals, then it's easy to figure out what the slope and the y-intercept are going to be. The slope is just the coefficient of x, the variable, and the y-intercept is just the constant that does not have a variable attached to it. And we can use that information to graph the equations very easily. All right, for the last one should be the substitution method. We know that one of the equations is solved for a variable. That's this equation here. It already says y equals. The other equation doesn't say y equals, but that's okay, because what we're going to do is take the information for one variable. We know that y is equal to x plus 4, and we're going to substitute it into the other equation. So instead of y, we're going to write down x plus 4. Then once we write down that x plus 4 into that equation, we solve the equation. We get the value of a variable that way. All right, so the general idea is when you're looking for a particular method to use in order to solve a system of linear equations, you're going to be looking for three different things. One thing you're going to be looking for is opposite terms, inverse terms. If you see opposite terms in the system of equations, that means you're going to try to add those equations together and try to eliminate that term. When you see both equations say y equals, they're in slope-intercept form, that is a real good indicator that you should be graphing these two equations. If it's already in slope-intercept form, that means that you can identify the slope, identify the intercept, and then graph them very easily, and then find the point of intersection. And lastly, the substitution method only requires one of the equations to be solved for one variable. It could be solved for y, could be solved for x, could be solved for whatever variable you want. If one of the variables is solved for already, you'll substitute that expression, whatever it happens to be, into the other equation and then solve that equation. In other words, you're combining the two equations together. All right, now that you have that information, let's try to actually do the work. The first one is substitution, so I'm going to take this system of equations and write it down there. Y equals x plus 4 and 2x plus y equals 1. All right, now it's down here. What I'm going to do is take this y equals x plus 4 and say, I know that y is equal to x plus 4. Let's get a marker for this. Since that x plus 4 is the same as saying y, that means it can be replaced anywhere you see y. I'm going to take this y out, and I'm going to replace it with x plus 4. So in other words, I've taken y out, and I've substituted it with x plus 4. Now what I'm going to do is try to evaluate all the terms on the left-hand side, and then try to solve this equation. So my next step is going to be to take this out of the parentheses, because there's no multiplication going on here. Sometimes with a problem like this, you'll have to take the number that's on the outside of the parentheses and distribute it, but there's no number here. There's an understood to be a 1 there. So 1 times x is x, 1 times 4 is 4. We move on with our lives. 2x and x combined together is our next step. And we see that 2x and x combine to 3x. The 4 comes along for the ride, and so does the 1. Now I'm going to take this number and move it to the other side of the equation by subtracting it from both sides. And I come up with 3x. There's no more 4 anymore, so 3x is equal to 1 minus 4, which is negative 3. Last step is going to be to divide both sides by the coefficient of x, which is 3. Once I do that, the 3's on the left-hand side eliminate, and then the negative 3 divided by 3 just turns into negative 1. So I know the value of x is equal to negative 1. I'm not done yet, though, because I need to find the values of both x and y. Remember, this is a system of equations, and a system of equations has x's and y's involved, and the solution to a system of equations is going to be 1 point on the graph. It's going to have an x value and a y value. So let's try to find the x value. I'm sorry, we have that already. Let's try to find the y value by substituting x into either equation. I think I'm going to choose to substitute it into that first equation, y equals x plus 4. So now that I know that x is equal to negative 1, I can substitute it into the equation. And then I'm going to evaluate it by doing negative 1 plus 4. That, of course, should give me positive 3. Now, sometimes students ask me, well, why did I choose to substitute into the first equation? Why can't I choose to substitute it into the second equation? Well, my answer is you could do that. Here, what I've done is written out the second equation and substituted negative 1, the value for x, in for x, right? 2 times x is the same as 2 times negative 1. And now what I'm going to do is try to solve for y. First, I'm going to multiply 2 times negative 1, which gives us negative 2. Then I'm going to take this negative 2 and move it to the other side of the equation by adding 2 on both sides. And my answer for y should be, you guessed it, 3. So you should be able to see that it doesn't matter which equation that you substitute the value of x into, you're still going to get the same answer for y. Right? So my suggestion to you is pick the equation that's shorter or easier or has less negative or whatever, or smaller numbers. Okay, so my answer is x is equal to negative 1, y is equal to 3. Here's my solution. Okay, that was the substitution method. Now I'm going to move to the elimination method. That's on the back of the sheet here if you received the sheet from me in class. So the elimination system that we're going to be working with is 2x plus 5y is equal to negative 2, and negative 2x minus 7y equals 6. Let's place that onto the appropriate place on the sheet. We'll take this system of equations and we'll bring it into the other place. Now what I want to do is actually do the elimination, which starts off with taking these two equations and adding them together. I'm going to add the x terms, the y terms, and the constant terms. Of course, the reason we selected elimination for this system in the first place is because 2x plus negative 2x eliminate each other. They cancel out. So 2x plus negative 2x gives us a 0. But I'm really not going to write that 0 here because the rest of the equation is going to have actual numbers and variables in it. I don't want to write the 0 because these two terms have been eliminated. I don't want to confuse myself. I'm going to get rid of that 0. I am going to do 5y plus negative 7y by, though. That should be 5 plus negative 7, which is negative 2y. I still have an equal sign in the middle here, in between the x's and y's and the constants. So I'm going to keep that equal sign down here. And I also have 6 plus negative 2, or negative 2 plus 6. Doesn't matter because the commutative property of addition says that it's going to be the same answer. Negative 2 plus 6 is going to be positive 4. And then in order to finish this off, I need to get y by itself to solve for y. So I'm going to divide both sides of this equation by negative 2. Notice I started off with two equations with two variables each. Now I've added the two equations together. Now I have one equation with only one variable. It's a much easier equation to work with. That's why elimination is so great. Okay, let's add these. Let's divide both sides by negative 2. So the negative 2 is on this side eliminate, leaving us with just y, and then 4 divided by negative 2 is, of course, negative 2, making our answer for y negative 2. I'm not done yet, though, because I found my value for y. I also need a value for x. I need to solve the equation for both variables. And now, remember, I could substitute the y into either equation to find x. I'm going to choose the first equation only because there are fewer negatives, right? There's two negatives here in this equation. This one has fewer negatives, so I'm going to use that one. It's really a better idea to try to pick the less complex of the two equations. So now that I've written out the equation, what I'm going to do is take y equals -2 and substitute it into this equation for y. And now I'm going to evaluate 5 times -2, which of course is -10. Further, trying to make the equation say x equals, I'm going to try to take this number and move it to the other side. I'm adding 10 to both sides. And then now that I know that x is equal to 8, 2x is equal to 8, I should say, I'm going to divide both sides by 2 and get x is equal to 4. And there is my answer. In the previous problem, I did substitute the -2 that I got. I did substitute the value of the variable into the other equation. The reason I did that was so that I could show you that both of those values, once substituted into the equation, would get y equals 3. I'm not going to do that here because you should know by now that it doesn't matter which one you substitute, which equation you substitute your value in, you're going to get the same answer out. So anyway, we have -2 as the y value and 4 as the x value. We're going to write out what our solution is then. Be careful of the order here. I know y is equal to -2 and x is equal to 4. The x value, of course, goes first, x comma y. So it should be 4 comma -2. Moving on to the last one, which is graphing. Let's pull that graphing system of equations from that front page and try to graph these two up. Here they are in all their glory. And now we'll put them next to the graph. There's an advantage to having the equations in slope-intercept form. The advantage is you know what the slope is and you know what the y-intercept is for both. You could use substitution method here. You could say, since y is equal to x minus 5 and y is also equal to -2x plus 7, you could set x minus 5 equal to -2x plus 7 and then solve that way. I think I prefer to graph it, 1, because we've already done a substitution method, and 2, because the graphing method is really satisfying. It gives us one point that's easy to find. All right, so let's identify the slope and the y-intercept of both equations. First things first, the slope of this first equation is equal to 1. I know it's 1 because there's no there's no coefficient in front of the variable here, so I'm allowed to put a 1 there. X is the same as saying 1x. So I know that my slope is 1. I'm going to convert it into a fraction so I can use rise over run. Since the slope is 1, we're able to write it as 1 over 1. Any integer can be rewritten as that integer divided by 1. So my rise is 1, I'm going to go 1 unit up, and my run is 1, I'm going to go 1 unit to the right, starting from the y-intercept. Speaking of the y-intercept, let's identify the y-intercept. In this case, for this linear equation, it's just the constant term at the end. -5 is the y-intercept. So I can start plotting this right now. If my y-intercept is 5 and my slope is 1 over 1, I start here at the y value of -5 on the y-axis, right? Then I know my slope is rise over run both 1, so rise 1, run 1. And then I put another point there. Rise 1, run 1, put another point there. And I continue putting points in that particular pattern, going upwards and over by 1 every time until I make a straight line. So I have my straight line drawn. I used my straight line drawing tool. You would use a straight edge like your student ID or MetroCard. And I also labeled it with y equals x minus 5. And I also extended it to the edges of the graphs and put arrows at the ends. These are basic concepts when it comes to graphing linear equations. Now let's take a look at the second linear equation, which is y equals -2x plus 7. First, let's identify the slope and the y-intercept. First, we can identify that the slope is -2. It's the coefficient of x. So I can write the slope as -2. I'm going to rewrite it as a fraction so I can get a rise out of run out of it. That means from one point to the next point, I'm going to rise, in this case, downwards by 2, and I'm going to run, which is always to the right, by 1. Then I'm going to identify my y-intercept, which is going to be my starting point. So my y-intercept is, in fact, 7. So what I'm going to do is start from 7. I'm going to go upwards by 7, which is here. That's my starting point for this equation. And then I'm going to follow my slope. The slope says I go down 2 and then over to the right by 1. So down 2, over to the right by 1. Put a point there. Down 2, over to the right 1, put a point there. Hopefully a little bit less of a messy point. And then continue downwards. And you'll see at one point, these two lines should intersect with each other. You can see I've labeled my line with y equals negative 2x plus 7. I've extended that straight line to the edges of the graph. I've put arrows on the edges as well. So now I'm going to take a look at my graph and try to identify where the solution is. Pretty easy to spot because the solution is where the both lines intersect. That's this point here. So in order to correctly and completely answer this question, I need to state my solution, which looks like this. I've identified the point at which these two lines intersect is 4, negative 1. So there's my solution. All right, this was the video on solving linear systems using 3 different methods. We did the substitution method, we did the graphical method, and we did the elimination method. All right, students, good luck studying.